In this video, I'm going to go over the structure of the cabinet carcass, or the skeleton of the cabinet. There's usually two types of cabinets carcass. One is made for the base that is on the floor, and the other one that is made for the wall. There's not much difference except obvious differences, like there won't be any drawers usually on the wall cabinet, and plus structurally the wall cabinets are made in such a way that it has elements in it that help to screw it securely to the wall. But in general, there is not much difference between the two. Now let's look at the different parts of the cabinet carcass. I'm going to focus a little bit on the base cabinet itself, but it's the same for the wall cabinet too. So I'm using SketchUp to highlight and hide the different parts. So this is the side of the cabinet, so to speak, the left and right. And that will obviously not finish the box. Since we need a box, you need a horizontal parts to it. So these are the horizontal parts for it. The top are called usually stretchers, I think, or the horizontal slats or horizontal supports. That different people use different words. And the bottom is the base over here. And then you have the toe kicks, which is in the bottom, below the base, like this. This toe kick on the front and on the back, which is not exactly a toe kick, but it's the same for support from in the front and back. Then you have the back parts of the cabinet, which are the top back, usually to nail it in, and then you have the back panel over there. And if there are drawers behind the doors, usually there's a drawer on the top over here in most base cabinets, but there could be also drawers underneath behind the door itself. So if there is drawers behind the door, as I explained in my previous video, there needs to be 1/2 inch extensions, because the drawer slides won't open with the door hinge in place. So you need 1/2 inch extensions, but I won't focus on that right now, so I will remove that. But this is typically what it is. This is the construction of the cabinet, and it's the same for both of them, for the wall cabinet and the base cabinet. Pretty much the same. You will see the two sides, so to speak, and then you will see the horizontal parts to connect it. Then you'll see the toe kick, which will be only in the base cabinet. Then you'll have the back top to connect to the wall or to give support on the top. And then this is a back panel. It's just covering the back. Now this is the structure that I chose for my design. There could be variations in this design. Some may put 3/4 inch plywood all the way from front all the way to back, but I want to save on my expensive plywood that I plan to buy, so I just did 4 inch over here and 4 inch on the back. Also on the very back panel of the cabinet, some people could use this whole back can be covered with 3/4 inch plywood. So instead of just 3/4 inch on the top, it could go all the way down to cover the whole back. But again, that's would probably make it a little bit bulky, heavy, and again I would lose 3/4 inch space to all the way down. So I'm using 3/4 inch only on the top for structural strength, and then I'm using a 1/2 inch back panel on a rabbeted end. When a rabbet end is basically this particular kind of construction where I put the back panel on top like this, and then underneath it, just on the way down at the bottom of the cabinet, is just going to rest over here on top of the back stretcher right here, which is parallel to the toe kick in the front. The other variation or other consideration is the base part of the cabinet. So the base part, depending upon how much weight is going to go on this base part over here, I plan to use pocket holes to connect. But if there is a lot of weight going on it, this could be put in a dado, in the sense that there could be, this base could be 1/4 inch wider, and it will go inside the side panel by 1/4 inch on both sides. So it will go in a 3/4 inch groove from front all the way to the back of the side, and the base will go inside the 1/4 inch depth, so that gives a little bit more strength, so to speak. So these are some of the variations I might one might consider, but this is the design that I'm going to go with. Now let me go through some cutting and assembly strategies for these cabinets. I'm going to go through a list of those that I thought of. Number one would be the grain direction. I can see that the grain direction is going up like this, and the grain direction needs to be the same all the way around in a clockwise direction or anti-clockwise direction, but they need to be the same direction from all the way around on 4 sides. Second point is that plywood comes in different qualities, and sometimes plywoods are marked in such a way that only one side is good quality, the other side is not so good quality. So I will have to decide beforehand which side of the plywood I will be using that will be exposed. So the good side of the plywood, which is in industry language called the A side, is usually, I might decide to be keeping it inside, or I might decide to keep it outside, but I have to decide that beforehand. Sometimes, and I'm moving on to the third point, there is bow or a bow or a bow in a plywood where the plywood is bent, so to speak. So if there is a bow in the plywood, then the bow should be pointing outwards, not inwards, on all 4 sides. The fourth point is about measuring and cutting. Cabinet building has to be precise, so I cannot really measure each horizontal piece by hand and then cut it by hand. We need specialty equipment like a table saw with proper measurement tape, or a miter saw with proper inbuilt measuring facility, or a crosscut sled with inbuilt measurement tape, and I would cut it in such a way that I would gang cut, in the sense that, let's say, all the horizontal pieces right here, on that here, here, possibly the toe kick on the back stretcher, behind the toe kick all the way to the back, they all have to be the exact same length, and possibly I have to cut them all together one after the other without disturbing my stop block, so to speak, or the measuring device or the measurement tape. If you don't know what a stop block is, you can see that in my previous video where I made the crosscut slit with an inbuilt measurement tape and stop block. But they all have to be cut together to be precise. The next the next point would be about the drawers. It's always it's a good idea to cut the drawers, especially the drawer fronts and the drawer backs, because the drawer fronts and back will dictate the width of the drawer, and they have to be cut accordingly. So if the drawer is on the top, including considering the drawer sides, which are 1/2 inch wide, then I have to cut the drawer front and back 1 inch smaller. If the drawer is on the bottom, then I have to cut it by 2 inches smaller because of the extensions that I'm going to give, that I talked about before. The next point would be about when all this wood is cut, it's easy to get lost track of it. So it's always a good idea to mark them, either mark them directly on the wood or put a tape on it and mark them, and give it some kind of convention that I would understand. So let's say C1 D1, for example, or let's say C1 stands for first cabinet, D1 stands for first drawer from the top. Whatever it is, I would probably build a convention to decide and mark the wood as I cut it, so later on it won't be an issue to assemble it properly. The next point would be about shelf holes. Usually there is adjustable shelves. If there is no drawers, there's adjustable shelves on this side, on the front and back, and also on the other side over here. So there's adjustable shelf here and here, and that needs to be put in before I put this back cabinet in, so the back panel in, because otherwise I cannot put the shelf pin. So before I put the back panel in or screw it in, which should be the last thing I do, I will put the shelf pin holes in, if there is a need for shelf pin. And the last point would be about pocket holes. I'm going to be using pocket holes, and the way I should be putting the pocket holes in would be in a way that it wouldn't be exposed to the eye from the outside, so they should be hidden. So it should be in the back or under or something to that sort, so that it's not exposed to the user from the outside. So these are all the points that and the strategies sort of that I'm going to follow. In the end, I'm going to be exclusively dependent on my table saw and my crosscut sled that goes over my table saw. So the table saw will do all the rip cuts, meaning the cuts that are parallel to the grain of the wood, like this edge and this edge. And my crosscut sled will do all the cross cuts, which are perpendicular to the grain direction. So it will be this edge and this edge on both sides. The same thing for the base over here. My base is in such a way that it sits on the back stretcher. So if I may zoom in over here, you can see that my base is exactly half an inch smaller or less wider than the sides. That's because my back panel over here sits on top of the back stretcher. So my base goes 1/4 inch over the back stretcher, and the rest of the half inch is taken up by the back panel itself. But the rest of the cuts that are all the horizontal cuts, including the adjusted cuts for the drawer fronts and backs, they're all cross cuts. So they will all be done either together or one after the other on my crosscut sled without disturbing the measurement tape. So all the stretcher over here, on the back over here, this one, and the toe kicks on the bottom, this one, and the one on the back over here, this one, will all be cut together without disturbing the measurement tape and stop block as cross cuts. So that's it. This is overall the explanation for the cutting and measuring and assembly strategies. Thanks for watching.